But anyways, so you didn't have to do this, but really what you had to figure out is, you're gonna have x and y. They want to know what they are, right? In some cases, x has to be only certain number and y has to be only certain number so that these equations make sense. In some cases, it depends. X could be 1, x could be 5, x could be 9, all these things. Y could be this, or whatever. So there's multiple ways to make sure these two equations are right? In some cases though, doesn't matter what x or y values are, it will never equal to 0 and 8. So those are what we call undefined. So how are we going to figure out this whether like which is which, right? So we could simplify it, right? So let's see what here. Are we allowed to simplify? Yes, we do. So we're gonna. So basically, oh yeah. This is something we need to talk about. I thought we didn't have to. So we have this rule called the elementary row operation. Elementary row operation. Kind of scary what non-elementary row operations are later on, if such a thing exists. It's on page 7 for people who like to read it. But honestly, it just means whenever you have matrices, we can manipulate them so that we can reduce it or simplify it so that it's easier to work with. Just like, for example, if you had 2x plus 2y equals 2. Whatever you do on the left side, you do the same on the other side, just like when you have a sibling, right? If you have a brother, let's say, and the parents give them $5, you're gonna be, a little upset, right? You want $5 as well, if not more. So because of that, so in order to get rid of these two coefficients, I can say divide it by 2. Both cancels out. But if I divide 2 on left side, on the right side, I have to do the same. Because that's the whole point of equal sign, right? Whatever you do here, you should do it here. The same way, right? So that's really all there is, elementary row operation. Three specific rules. It says it better on page 7. But so what you could do is whatever row you have. So this is row 1 and row 2, right? Or later on you're gonna use line 1, line 2. That's the format that seems to be using. But nonetheless, so this row 1, let's say if I wanted to get rid of this 1, right? Then you could just do row 1 or line 1 minus line 2 equals to line 2, for example. Now, where did all this come from, right? So basically, let's say I wanted to get rid of the 1, right? So I can do is, 1 minus 1, that will be 0. Unfortunately, we have to do the same for all the unknowns, right? So if I did row 1 minus row 2, then I have to do the same on this side, right? So negative 2, you can't use minuses, yeah. So you can minus, but this is a technicality, right? So we can't make this negative 1. I mean, technically, overall it doesn't really matter. But we don't subtract. We can only add rows to another or whatever. So if you want to get rid of this 1, just say line 1 times negative, right? Negative 1, right? That way 1 becomes negative 1. Then once it becomes negative 1, negative 1 plus 1 will be 0, right? So that's the technicality that we need to get into. So negative L1 minus L2 is the same, so that equals to L2. Now, how did I come up with this equation? It's because I want to change this L2, right? So that was my strategy. I get this number, and then these numbers have same coefficient, so if I subtract them, this will become 0. So let me actually show you so that this makes more sense. So if I do this, let's just go through this first, then we can explain how this came about to be. So 1, negative 2, 0 stays the same, because the only thing I change is L2. I can change L1 as well, but one at a time, right? So 1, negative, that's a plus, right? So it's not plus, because we can't do negative between rows, right? So negative L1, which is 1, plus negative 1, plus 1, because L2 is 1 over here, that is 0. So we write 0. Same thing with here. Same thing with here. Negative 2, but remember this is minus, so that's going to be positive 2, plus negative 4, So negative cancels out, so it's going to be 2 plus negative 4, that's going to be negative 2. So we put negative 2 here. Same thing, 0 times negative doesn't matter, is 0 plus 8 is 8. So that will be the equation. Now we're going to see why this equation came about to be. It's because, remember I was saying about how the unknown has a unique value and that's a good thing? Here's why. Negative 2 and 8, right? So that's negative 2. Whatever unknown you just saw, here is y, so let's stick with the same consistency, equals to 8. Oh, well, that's simple algebra. Divide both by negative 2 by negative 2. You get y equals to negative 4, right? This is definable, so that's a good sign, right? Now, so going back to x, so remember this is still equation, right? X negative 2y equals 0. Well, let's see if that's true. If y is negative 4, then it's going to be x equals to negative 2, negative 4, not equals to, sorry. Minus 4 equals to 0. So that's going to be x plus, because negative cancel out, 8 equals 0. X, so move the 8, minus 8 on both sides. So x is going to equal to negative 8. So we have x and y with defined values. So that's why this is consistent. Oh, no, not the term you will be using later on. This will have a unique solution, right? So that will be the answer, right? But suppose that I have a different case. Let's say I have this, right? So instead of, okay, right, so ignore all this. Let's assume this is the equation that we managed to reduce into, right? So if negative 2y equals 0, okay, so that's gonna be y equals 0, and that could be definable, but okay. But for our purposes, when you have any unknown that equals, so any unknown's coefficient, if they equal to 0, yeah, no, actually, that still works. Never mind. Sorry, my apologies. You're gonna have negative 2y equals 0, so y is gonna equal to 0. So if that's the case, so that's another defined solution. I'm trying to give you like undefined solution. So let's say it was actually, yeah, let's do this. There you go. That makes more sense. So there's nothing, right? So it's just 0, right? Because equals to 2. Doesn't make sense. They cannot equal, right? So when these cases happen, then we say the solution is undefined because nothing is possible, right? Sometimes you're gonna have, and if infinite solutions was a good example. Infinite solution is gonna look like this. So you have nothing here, and there's nothing here. So if you have a line that says 0 equals 0, then it is undefined, not undefined. It has too many solutions, so infinite solutions. Be careful though, just because you see this doesn't mean it's a necessary infinite solution, right? So you could have this, but let's say I increase the size. So you have like that, right? So line 2 seems to suggest that it has infinite solution, but look at here, 0 and 5, right? Again, 0 equals to 5. Can't happen. So even though it has a 0 equals 0 characteristic, we say it's undefined. So think of it's like a hierarchy. Undefined triumphs over everything. So that's what you need to know. And more algebra intense, but the same question will be number 12. It's going to be 2x minus 3y equals a, and 4x minus 6y equals to b. Okay, so that's the case, right? So if you have a question like this, same idea. Put it in matrices format. Yes, you don't really Well, I'm just gonna put it in matrix format. You're not required to. You could just technically solve it using just using algebra to simplify what x and y is. But let's get a good practice because this is linear algebra, not calculus. So I'm gonna have this, right? So two equations, two unknowns. Don't really like it. I want the matrix to be a little bit more simpler. What are the ideas? Now, some might argue divide 4 by 2 and then do this. In general rule, especially when we get to 1.2 and beyond, try not to divide anything. Because, for example, let's say if I divide by 4, right? Then I have to do the same, right? And then you're going to have fractions. Try to avoid fractions like a plague. You won't be able to always avoid it, but fraction gets annoying, especially if the matrix becomes really big in size. Then you do a whole number minus the fraction, and then fraction minus the fraction, fraction minus the fraction. Not very good. You want them to be a whole number so that when you do subtractions or additions or whatever, the number stays simple enough for you to, keep going without causing mistakes and so forth, right? So I would actually encourage you to use a smaller one, right? So this one, what I'm gonna do is I'm just gonna keep it the same because again, if I want to divide this by 2 to make it as 1, which I'm jumping myself ahead so much, which you may have to do once you get to 1.2 depending on what question, but I'm just gonna keep it the same for now. So I want to get rid of 4. Well, what do? I can just write, L. That's gonna be L1, right? So L1, L1 times 2, right? Because if 2 becomes 4, then I can cancel out completely, right? Again, though, I can't do minuses when I'm playing with the row according to the elementary row operation or whatever that's called. So because of that, I'm gonna put negative sign here. So it's gonna be -4, right? 2 times -4, so 2 times -2 is 4. And then I'm going to add that with L2. Now, bear in mind, it may be a coincidence, but you don't have to start with L1. Maybe you want to start with L2 or L3, depending on what your matrix is, right? So, but I'm going to do this one because it's simple here. So that's going to be -4, so that's going to be 0. -3 times -2 is going to be 6. 6 plus -6 is 0. Oh, we might actually get. Oh no, we'll. I'm getting overly excited. Okay, so A times -2. So a -2A, right? Because L1 is A, -2. So, and then plus B. Right. So that's gonna be. It looks weird, but there's a reason why they asked this for, right? Because now they're gonna ask, so what are the A's and B's have to be so that it produces unique solutions or infinite solutions or undefined solution, right? So let's start with an undefined solution first because we know the rule, right? Y is 0, this side, right? Has to equal to some number. If it's 0, then it could be infinite solution. But if you put any number so that this becomes not possible, then it's undefined. So it's really simple, right? So that's -2A plus B. -2A plus B just has to not be 0, right? So I'm just going to put 0 here. I know it says equal, but so when we say, so if we make this at 0, and if we have A and B solutions, then anything but those solutions, it will become like this, right? So because of that, I'm going to move 2A, so I'm going to do this, -B equals, because I moved this side, negative cancel out, so 2A equals B. When 2A equals B, because it equals to 0, you're going to have 0 equals 0 situation. So if that's the case, when 2A equals to B, my apologies. So yeah, but you can see that 2A plus B. So if that happens in this situation, it's going to be infinite, right? So, whatever. So for example, so whole point of infinite is because there are multiple possibilities, right? So if I say A equals to 5, right? That's going to be the same thing, right? So in this case, A has to be 5 and B has to be 10. But it could be anything, right? I could put 2 and maybe 4. Same thing, right? So so that will be the infinite solutions. But let's say so remember, negative 2a plus b equals 0, right? So and then we say it was all right, a equals b, 2a equals b, right? That's what it was, right? If this does not happen, then it's gonna have it's gonna be undefined. So if I said a equals 5 and b was 9, say if 10 equals 9. No, doesn't work, right? Just like 0 equals something, right? 10, 9, they don't equal. So if that's the case, it's undefined. So that's all there is. For this one, it has no unique solution. Because that's x and y, let's say, right? So that y is never gonna be y could be anything and x could be anything. There are two factors, right? So all you have equation of, if you look at it here, so it's gonna be 2x minus 3y equals a, right? Well, a is an any number, right? X could be anything, y could be anything. So for this situation, there's no unique solution. Okay. Okay, so that's that. And we're almost getting close. 13 and 14, do we really want to bother doing this? Let's see, parametric, the solution of the linear set. Okay, so you're looking for the parametric equation to describe the solutions of the linear equations. So, okay, I'll just try a few. Try anything else. Oh, they do use a term contradictory. So, okay, there we have it. Okay, so, but anyways, let's do 14, let's say C. 14c, so it's going to be negative 8x1 plus 2x2 minus 5x3 plus 6x4 equals to 1. Wait a minute, negative 8. Oh, sorry, that's 13c. My bad, 13c. Okay, so if that was like, so that's 13c. So if we have that, then now we're trying to figure out what the defined solutions are. So I want to know what x1 is, x2, x3, x4. What are they, right? So for this situation, the problem is we have too many possible solutions, right? So it's going to be infinite solution. We're not going to have a unique solution, right? But we don't just stop there because they want specifics, right? So typically, this is almost like hierarchy. We look for this one. It could be either way around. Doesn't matter. But choose one of the unknown and just say, because it could be anything, right? So let's say I choose x4, right? It's gonna equal to some parameter, like let's say u, for example, right? So and then the important thing you need to say is must be real number. That's the technical term you use, right? So the reason why we do this, for non-math majors who just want to get the math out of the way, just think of a technicality, right? So this is the format the mathematics course accepts. That would just simplify everything. But I think the explanation I sort of got was that the reason why we do this because for formalities, right? So I think Professor Carlos, I think he was explained this to me. So basically, like let's say there's a world convention and the scientists are talking to each other, right? If I say right and you say right way or right hand, they all mean the same thing, right? But it could get confusing. So this is the format they used. We don't use the unknowns. Also because when we deal with more matrices, we could get confused, right? Wait a minute, so x4 is, I keep thinking it's unknown, right? But maybe it just has to be some number, right? So if I look at this, my psychological reaction is, oh, it's some kind of unknown. What is it? Like I have to find that out, right? But if I replace just that with u, then like, oh, it's just any number, right? So that we can get that out of the way, right? So that's why. So now if we have x3, again, there's only one equation, so we can't really do what we were doing before, right? Undefined, defined, and so forth. So I'm just going to make x3 equals to some other parameter. So let's say, okay, n for example. Yeah, n for example, right? So that's, and then n is a real number. x2 is, again, I'm gonna, any number, a, and it's real number. x1 though, I suppose we could do it for everything, but it defeats the purpose. So we could say x1, so negative x plus 2, and I'm actually going to sub it in now, right? So to a minus 5n plus 6 u equals to 1. That way, let's isolate for x1. So I'm going to move everything to the right. So it's going to be 1 minus 2a plus 5n minus 6u. Divide the whole thing by 8. No way I'm simplifying this. Or negative 8. And that cancels out because it's divided by negative 8. So the x1 is going to equal to all this. Where a, n, and u could be any, are all parameters. So it could be any numbers you want. So if someone asks, this will be infinite solutions, but this is what we do, right? For a parametric equation. That's what it's called, right? So that sounds really, that doesn't seem to have a lot of point to it, right? But so let me just try one more, because that was not the best equation. Oh no, actually, that's what's gonna be. Yeah, so simply because we have one equation. If you have multiple equations, right? So multiple rows, right? Then you can actually say some, let's say it was like x1, x2, x3, just like before, right? But like if I have multiple equations or multiple rows, remember what we did in earlier questions? It's like, oh, we can cancel some of them out. Or we could say x4 equals to whatever, right? Then maybe the next equation is x3 plus x4 equals to whatever, right? So then if I know what the x4 is, and I know this number, I can just do, like let's say x4 was 5, right? Equals to 0, right? Then we can actually find out the x3, which is negative 5. And we can use the x3 to figure out the pattern continues, right? So we may not be able to go all the way. Maybe we can only go up to x3, and then for this case we may have to say x2 is a parameter. We know x3, x4, so x1 will be whatever. But so that's the idea, right? I think we do a little bit of that in 1.2, but so that pretty much covers 1.1. You don't have to really worry about doing even questions. Just stick with the odd for most part. But later on, we may have to do a little more even questions. And I'll talk about that in section 1.2. I think this video got really long. Anyways, so yeah. So I hope you guys found this useful, and I will see you again in section 1.2.